After seeing the media storage project in our previous issue, many of you inquired about our CNC router and what the status is of it and so forth. So we're going to start a short series on the particular machine, explaining a little bit about CNC routers, how they work, how they got started in time and history and so forth, so that you can become a little bit more familiar with one of the more modern machining tools that we use in woodworking. Now granted, CNC routers aren't really a hobbyist type tool just yet. They're actually getting very low cost, and as such, they're starting to show up more and more in hobbyist type shops. However, in larger cabinet shops, CNC routers are actually becoming quite the popular item these days. Now to get an understanding of CNC, let's go back in time. Back around World War II, a company, Bell, was manufacturing a new flying machine called a helicopter. Now the complex componentry of these helicopters required the machine shops to manufacture very complex fixtures and tooling to not only hold these complex workpieces, but to also machine them. So they're actually credited, Bell, with designing and developing the first NC machines. And it was for the purpose of manufacturing complex parts. Now the earlier machines were NC, not CNC. CNC is an acronym that stands for Computer Numerical Control. Now in the earlier days, back around just post World War II, they were NC, numerically controlled. They didn't have computers like we do today, so they actually had to hardwire all the circuitry as opposed to running it through a computer to do the processing of the information. It was very, very complex, pretty much unreliable, but nonetheless it was the basis for what we use today in CNC. Now the first commercially available NC machine tool came to market in 1955, and I believe it made its debut at the International Machine Tool Show in Chicago of that year. Now, moving forward in history, about the mid-1970s is when CNC actually became common. Computers were becoming very commonplace. In the early days of CNC, we didn't use personal computer type computers. They actually had a very proprietary computer structure. It wasn't something that you could load your word processor in and start typing a letter on it, so to speak. They were special computers designed specifically for running the CNC machine tool. In more recent years, perhaps within the last 15 or so, many software developers have taken the time to design software to run on a standard computer that will run machine tools. Now as time went on, relative to our hobbyist woodworking industry here, as time went on, many home computer programmer guys, or women for that matter, started developing their own software. As programming became more common and people got better at it, hobbyists took it upon themselves to create the application software, the CNC control software, to run on personal computers and deliver it to the market at a very low cost. Now surprisingly, to give you an idea or a comparison, an industrial controller, for example, the brand name Fanuc, one of the largest and most populous controls in the industry, could have cost you upwards of $20,000 or $30,000 for the controller, the computer, and the software. This software that we're using today on the CNC router will cost $150, and it will run on any Windows-based computer that's running the XP operating system. So that kind of gives you a caliber, a scale to measure how far the industry's come. In other words, what we're saying is CNC is becoming commonplace. It's no longer a black magic or a very unusual type of application or product. It's finding its way into more and more applications. So that kind of gives you a background of CNC or NC and how it's progressed up to the current state of it, which is literally from the largest of industrial machines to the smallest of home hobbyist type machines. So now what I'd like to do in this first part here is kind of walk you through the mechanics of how this machine actually operates. Then in future issues of the magazine, we'll point on other fine elements of a CNC router, how they work, and pretty much how to build one, we hope, at some point in the future. Now this is our prototype. We built this here in the shop. We tried to use as many commonly available materials as we could. There's still some custom machine parts that we had to obtain, but we're looking for additional sources on some of those components so that hopefully we can put together a project for you where you can build your very own CNC router at a very low cost. Now the whole point of CNC is computer numerical control. We're going to take numbers and control a machine, numerical control. Now the computer's function in this is to coordinate all that information, translate it, interpret it, and send those signals out to the motors on the actual machine tool to cause the motion. Now here are the various codes that are used to control this machine. You can see that we've got some G codes, some X, Y, Z codes, F codes, M codes, a whole variety of different codes to make the machine tool do various things. So these are the actual numbers that are controlling the machine. Now we'll get into more details of this at a later time, but for right now, this is considered the CNC program. Now that CNC program has to be interpreted by the controller software. Now the purpose of this software is to take those G codes, translate them into something that the machine needs to do, and to control the motions of the machine, not only positionally, but in velocity. In other words, you want the tool to move from point A to point B at a given speed or a given feed rate. And that's the purpose of the control software. Now there's many other features of the control software that allow us, the operator, to interact with it and to give us precise control over the machine tool. Now this particular software that I mentioned a moment ago cost $150. It's called Mach 2 and it's made by Artsoft Corporation. All around, we've only had it in our facility here for a couple of days now, so we really don't fully understand it yet. We've been able to implement it on our machine, get the machine up and running, and actually even run a test part in just a matter of a few hours of setup on it. As I mentioned, the software interprets all those commands and sends them out to the computer. The computer will then send them out through its parallel port, which is what you normally hook up to your printer. Now that particular port on a computer is very good for controlling stepper motors, which are the motors that are causing the various axes to move. So that data comes out of the computer through a parallel port into this particular box. Now coming in through here is that parallel printer cable. And that's what actually feeds the data into this particular board, the driver board. Now as I mentioned, this is the lowest cost unit we could find. And its only purpose is really just to give us a place to hook up all the motors and switches, to amplify these very low power currents coming out of that parallel port, amplify them, and then output them to the motors. So we've got our low voltage coming in, small lightweight pulses of electricity. This amplifies them and then sends them out to the motors. Now we do have to have some resistors in here to control the current going out to the motors so that we don't overheat them. Now this is a power supply, and if you've ever opened up a computer, you'll notice that, gee, this looks like the power supply from a computer, and it is. It's about the lowest cost and most economical type of power supply you can use with stepper motors of this configuration. Now it is not the best power supply for this type of application, but it certainly does function as you've witnessed in the videos. Quickly again, low voltage coming in, driver board amplifies signal, takes power from this power supply, sends it out to the motors. Now we've got a couple of switches up here that we've installed for safety and so forth, and to turn on and off various components of it. And the all-important emergency stop button. When this goes in, all the power drops off to each of the motors. Now we can look at the drive mechanics. Now as we know, we've got our electrical cables coming into the motor from that driver card up above. This motor is a stepper motor. It can only move one pulse at a time, but you can do it very rapidly and it will actually rotate in a continuous motion. But we get very precise positioning and very precise velocity out of this type of motor. The motor is connected to the lead screw, which in this case is called a ball screw. It's a very precise, low friction screw, and in between is a coupling. Now what I'll do is I'll make this motor move one pulse at a time here so you get an idea of how slow it goes. You can even hear it kind of thumping. Now each time it does that, it's moving my table 1/1000th of an inch. Now as I mentioned, that's one pulse for every time it moved 1/1000th of an inch. Now if we tell that motor to move a number of pulses very quickly, we get a continuous motion. Now here's a very slow motion. You can almost hear the individual thumps of that stepper motor making each movement. Now we'll go a little bit faster, and a little faster yet. Now not only do we have to concern ourselves with the motion regarding the motor, the coupler, and the ball screw and nut, but we have to provide a means to allow that saddle to slide along that axis. And that's the purpose of these two components. These are called the ways. Now, obviously they're an extruded aluminum product, and we're using UHMW plastic as a bearing block. And it actually works out very efficiently to give us a nice slippery, smooth surface that's precisely guided and yet rigid and will dampen the vibrations. So this is a very important aspect of the design of a CNC router. Now one other aspect I'd like to point out while we're in this area, you'll notice right here a little switch with some trip dogs. Well, this switch is what's called the limit switch. We don't want the machine to go past this point, otherwise we're probably in an interference area. We're either at the end of the travel of the ball screw and nut, or in this case, the base of the router is hitting the table. So we have this switch to prevent motion from going down too far or up too far. And we would have one of these switches on each of the three axes. Now those motions you just saw me making were manually controlled through the CNC control software. Now what we'll do is we'll start running that program without a workpiece to show you how the CNC control interprets all those codes and causes a nice coordinated movement to create circles and lines at any given angle. Now this is what's called a rapid move. It's going to position as quick as it can from one point to another. Now it's actually going through and milling a circle, each one of these little circles that we see here. Again, as CNC controls not only have to control the machine, but they also need to provide a way for the operator to control it during program execution. And one thing that you may find very handy is the ability to override the rate of feed. So I'll slow that way down now. And here you can hear that motor slowing way down. So I have complete control over how fast that tool moves during the rapid movements from point to point and the actual feed motions as it's cutting. Now earlier I mentioned that the machine has three axes of motion. We have our long axes, our left to right axes is called the x-axis. So any point I want to move along this way would be addressed with the letter X. Our other axes of motion on the table is in this direction. Right now it's moving in the y-axis. That's fore and aft. And if I want to position the tool anywhere along this way, I would precede that position command with the letter Y. Now you'll also see the tool moving up and down. Right here is a Z move. This is our Z-axis of motion. Anything up and down is the Z-axis. Now this machine can move all three of these axes, X, Y, and Z, all at the same time. So that literally gives you the capability to do 3D sculpting and so forth. However, I will caution you right away, 3D programming and 3D sculpting is something that's very, very difficult to do without very good CAD software or having an original model that you could digitize into a CNC program, of which many of these types of machines can be retrofitted with a digitizing tool that allows you to go through and make a program from a solid model. Now we will be revisiting the CNC router in future issues of Woodworking at Home magazine. I'm Chris DeHut. Thanks for watching.